will be the story of, it's my version of Sex and the Sea, but Carnival won't let me use the word sex. So it ends up being reef romance. And then we'll finish up, we'll talk about some of the wild places of Southern California. Places for you that if you're going to hang out, maybe for a couple of days, we can talk a little bit about Southern California environment. And then Baja is just a couple hours south, and I'll talk a little bit about that as well. Northern Baja, many of you may have been to Cabo, yeah. All right, here we go. Here's what we're going to talk about today. This is going to be a little bit of a mix here. We're going to talk about how animals sense the environment and how they use their brains in different ways than we may do it. And we may use our brains. And I thought I'd give you a little bit of a taste of this, of this concept that animals sense and see the world a little bit differently than we do. And we're going to talk about why they do that and how they do that and the reason that they do it. And they have these built-in senses. And I want us to get away from the idea that something is better than something else. Oh, this animal hears better than this animal does. Or this animal sees. It's not a competition. But they have those abilities because they need it. Which animal has some of the best eyesight on the planet out of the entire animal kingdom? Humans. Yeah, give yourselves a break. We have some of the best eyesight on the planet. Yes, it's true. An eagle can see a mouse from 1 mile away. That is true. But once the light dims, all of a sudden that eagle's eyesight is gone. That acuity is gone. And who can step in and do it and see better during twilight, dusk? Us. We can see much better than an eagle can see at dusk. So, and you might ask, well, why is that? Well, why do they need what they've got? They need to be able to see a mouse from 1 mile away. Do we? No. We don't need that. But we need to be able to see longer in that twilight period. So it's not a competition really, but it's more of an investigation about why animals have these abilities and how it helps them. And also how they see the world differently than we do. And how they use their brain. We interact with our environment. How we interact depends upon our senses. And we've got basically these 5 senses, but there are other senses as well. For example, when we're sensing light, this is what it looks like. We've got a lens, we've got a cornea, we've got a lens. This lens focuses the light back into a very small point on our retina, and then that creates chemical signals that are turned into electrical signals, and then those go to our brain, and then we interpret those signals however we interpret them. And brains will create this image that can be based on the actual event itself as well as past experiences too. These are the wavelengths of light that we are able to see. We see, where did my little thing go? Well, I don't know where that went, but I kind of got, here it is. That's what I was looking for. All right, we've got reds, greens, and blues. And this is the part of the we call it the electromagnetic spectrum that our eyes can detect. In other words, energy that is in that wavelength. Anything that is beyond that, infrared, ultraviolet, we are not able to see. And we're also, our eyes are not designed to polarize light. If you have sunglasses, are your glasses polarized for that? Some animals have that ability built into their eyes where they can polarize light. This is what it looks like when we take that information, beautiful Hawaiian sunset, and that's what we get. In comparison, we've got this mantis shrimp. And some animals see colors that we can't even imagine. We have 3 cones in our eyes. And each cone picks up those 3 different colors of light. The red, the blues, and the greens. These guys have 16. And when they see, they're going to see many more colors than we see. They're going to see something that looks like this. Instead of having those 3 peaks, they're going to have over 12 different peaks. And they're going to be able to distinguish all of those colors right there. But look at this, the shorter wavelengths. They're able to see these ultraviolet light as well. And we know the bees can see that. Their experience of sight is much, much different than ours. In addition to that, they're able to polarize light. And when they're looking at an image, they're going to see something that looks more like this to the right. This is a black and white. This is more what they're going to see. And you might ask the question, well, why is that? Why do they see the world like that? And it's because they need to while they're underwater, while they're in an underwater environment. And in those environments, it's not so important for them to be able to have depth perception. It's not so important for them to be able to distinguish between these colors. They're looking more for shapes, they're looking for prey, or they're looking for a mate. All right. How many times? Let's take, as an example, we're going to try this experiment. I'm going to show you a video, and I want you to watch this. And this is an exercise in perception. How we see what we see, what we catch, what we don't catch, how we see the world. And in this case, there's going to be a team. There's going to be a team wearing a white shirt, a team wearing a black shirt. I want you to keep track of the team with the white shirt that is passing the ball. And if you've seen this exercise before, don't say anything until we're done with it, and then we'll talk about it then. All right, let's give this a try. Keep track.
You're in the way.
You're in the way, you can't see.
Okay, hang on. Let's do this again. All right, see if you can do it. And I think there actually might be one more. Let me stand over here, and we're going to try it, and you count for yourself. Because to tell you the truth, I'm not quite sure that number is exactly correct. I've done this a number of times. All right, are you ready? Here you go. All right, that's it. What did you guys get?
13.
Did you get 13? That was what I got the first time that I did it.
I got
Not 12. For the white. And then you got 15. Yeah, I saw a couple. Okay. Did everybody see the gorilla? How many people didn't see it? Yeah. Did not see the gorilla. All right, let's watch this again. Like I said, sometimes this works, sometimes it doesn't. But the idea behind it is that you see it walking through the stage.
Yeah.
How many people missed that? You did? Because you were focused, it's because of where our attention, where our focus was,
Yeah.
right? And this is how our senses work. Even though we think we're seeing everything or we're hearing everything, not necessarily true. All right, here we go. Let's jump into the octopus here, real quick. The octopus has a complex eye just like us, and it evolved completely separate from the vertebrate eye. And in addition to that, the octopus is colorblind. And think about that for a second as we go through this. How is that possible? This is what its eye looks like. Rather than having a round pupil, it's got more of an oblong pupil. And what that does is it gives it this visibility of 180 degrees on each side. An octopus virtually does not have a blind spot like we do. We have a blind spot in our vision. In addition to that, the octopus is colorblind, but yet it still sees color. And the way it does, the way its lenses in each eye is arranged, it's arranged to be able to detect the wavelength of light and measure how that light strikes its retina and the amount of speed. And based on that, while it can't see color in the same way that we can, it can detect the difference between different wavelengths of light. And that is how it sees color. And why would that surprise somebody that an octopus is colorblind? Think about it for a second. Think about all the little videos that you may have seen about octopus. When they land on a surface, what do? They change color. Well, if they're colorblind, how do they know?
Very good morning, ladies and gentlemen, this is your captain, Luca Lazzarino speaking from the bridge, and of course I want to share some information about sailing and weather. We are sailing in the Pacific Ocean. The ship is 240 nautical miles northeast of Maui Island, traveling speed of 90 knots. The wind is blowing from east 20 knots, and we have 9 feet of swell coming from the same direction. From Honolulu, Hawaii, we recovered 330 nautical miles, and there are 2,000 nautical miles to reach Long Beach. Depth of the ocean in this current location is 16,400 feet. The weather forecast for today is a sunny sky, top temperature of 77 degrees. And tomorrow we expect a sunny sky with a top temperature of 75 degrees. Ladies and gentlemen, thank you very much for your attention, and I hope you enjoy this beautiful, fun day at sea. Bye for now.
Wow, that's deeper. That's deeper than I thought. We're at 16,000 feet. All right, back to the octopus eye. They're measuring the lengths of wavelength, and based on that, they have chromatophores in their skin, and they will change their color, but they're colorblind. Octopus have 500 million neurons, meaning that they have the largest nervous system of any invertebrate. And pound for pound, they are very similar to us in terms of the size of their brain. But it's not just the brain on an octopus that's doing the thinking. Unlike vertebrates, octopus are not, well, they're not just going to be thinking and sensing the worlds with their brain. They literally have brains in each one of their arms. Each arm has the ability to smell, to touch, to taste, and to sense light, which is kind of crazy. They have thousands of neurons in each one of their suckers. And those suckers, those suction cups that are on their arms, each one of those has almost a little brain in it. And these octopus will have their arms kind of moving. Everybody's seen an octopus, right? Kind of crawling around and so forth and sensing the world. Well, each one of those hundreds of suckers is almost like a little brain, like a little sensory system in and of itself. And they have a little bit of a memory with them as well. That's what one sucker looks like. On that sucker, there are taste buds. We only have taste buds on our tongue. They have hundreds of them all over each one of the arms. They can smell with each one of their suckers. Think about this world that this octopus lives in. It is not like our world at all, is it? Completely different. They can smell with each one of those. And you may go, well, how is that possible? Because when you smell, you got to have a nose. You got to be breathing in, right? All those all those smells that we smell, those are actually molecules. And for an octopus, he has the ability to be able to pull those molecules, take those molecules with that sucker, and then convert that into what we would call smell. So taste, smell. Also, the octopus has little cells in each one of those suckers. You can kind of see it there. Well, you can't really, but they're there. He has little cells there called photophores, and those photophores can measure light. And remember, they're colorblind. But what they can do is they can measure those wavelengths of light. And based on those wavelengths, this is how an octopus is going to change color. And this is how an octopus matches, if it so chooses, the environment that it's sitting on. They can recognize humans. They have the ability to identify humans as well. And squirt water at people they don't like. I guess that's their way of yelling. They can show interest in new items. They can play even though they're not edible. There's a curiosity element. They're escape artists. Everybody has heard this, how they crawl out of aquariums and so forth. And that's why in our aquariums we'll put that astroturf. And the reason for that is because they don't like that texture. For us, and anybody who's raised a kid, you know that kids don't like certain foods, right? And it could be because of two basic fundamental reasons, right? The kid is testing our patience. That's not it. That he may not like the taste of something, right? Like how many kids don't like broccoli, right? They don't like it because it tastes bitter to them. And by the way, when a kid says that, and you're going, there's nothing wrong with this, he's just being fussy, that's not true. It turns out there actually is a gene that they carry, and when they say it tastes horrible, it tastes bitter, they're telling the truth. But that's a sidebar. So it's either taste or, what's the other one? Texture, the same for us, taste and texture. For us, taste and texture are two separate. They're separated. You've got texture and you've got taste. With an octopus, not true. For an octopus, both of those blend into something, to a third item or a third sense in a way. And those come together, and that's how they're tasting their environment. The texture and the taste are not separated. They all go together. Do you get that? Because if you do, explain it to me, because I don't get it. It's a third test. It's almost like a third element of sensory. And part of our biggest challenge with analyzing this world of sensory is we can't, meaning scientists cannot help but do it through their own experience because they're humans. And this is how we experience the world. And it's very hard to step out of that. It's one of the reasons why scientists have so many instruments and gadgets. It's sort of like, okay, I gotta step out of this and I gotta let this do it so that we can get empirical data. But it's really hard to get empirical data with this stuff. Here's another guy. Disassembled valve on top of the tank and flooded the whole aquarium. This was down at Santa Monica Pier. We have an aquarium down there. Here's a little guy, a scar. Here's what he got into. Squirting water, kept turning out, blowing the fuse at the aquarium. And I'm telling you, the octopus knows it's doing this. Squirts water, everything goes dark. Happy as a clam. Throws out chessboards. Knows because it irritates the people running the aquarium. Juggles hermit crabs. The hermit crabs do not like to be juggled. Here. And just rearranging the tank in general. And then here, as we know, we've all seen these kinds of videos, master of camouflage. Can you see the octopus there?
Wow.
Crazy, isn't it? I know, I played that thing over and over again. It just looks identical.
Wow.
It's able to change its texture, its look, its color, everything. And how does it do that? It does it through the suckers, because the suckers can taste, The suckers land on that structure. It knows what the texture is. It knows what the color is based on its photophores. It's not its eyes. Its eyes are colorblind. But those suckers have like little tiny eyes on them. What a different world, huh? Meeting an octopus is the closest thing on earth that you're going to come to an alien. And it's probably true. Let's talk just a little bit about orca here. And we're going to talk about one pod in particular. This is North Gulf Oceanic Society. They're based out of Seward and Homer, Alaska. And they have been studied, they study pods that are up in the Gulf region of Alaska. And they've got one pod in particular that they have been studying. Dolphin's brain is more highly folded even than our brains. And if one thing we can all agree on, dolphins are intelligent. And they experience the world in many ways similar to us, but in other ways very, very differently than we do. To find their food, their prey, they use this process called echolocation. And I've got another little video here in a couple of slides that'll kind of show this, but just to get us started on this, they are going to send out sound waves. So I'm going to play you an audio of what these sound like. They're going to send these are coming out, are generated through the melon portion of their skull, and they're going to go out and they're going to echo. They're looking for food. They're not communicating with each other. Now this is an exercise where they're just looking for food. And when that hits a potential food source, it's going to echo back, and this fat-filled cavity that's in their lower jaw is where they receive that signal, and then they're going to convert that vibration, that electrical vibration, into an image in their head, much the same way we do with our eyes. We think of sound in terms of language, but they use sound for spatial awareness. They use sound to create a picture of their environment in some ways the same way that we use our eyes. When we look around this room, we use our eyes to create that relationship. Dolphins don't do that. Any animal that echolocates does not do that. And by the way, when I say dolphin, orca are a dolphin. They just happen to be the biggest. We call them killer whales because when we use the word whale, it usually means anything that's big. So we call them killer whales just because they're the largest dolphin. They're much, much bigger than any. So visually, they're going to use the saddle patches and eye patches. You can see those. Saddle patch just means that patch that's on their back. And they use that to help them understand the speed, direction of travel, and also to help identify other members of their pod. They don't speak to coordinate their attacks. Vocalization, this is shouting, like shouting out their last name down, or just shouting out to each other. Now here is what that vocalization sounds like. That's an orca. You got that? All of these orca that are out there are many, many different pods. And they all have their own dialect. They all have their own sound patterns. And scientists, biologists that study this are fascinated by it because they're able to now identify certain pods just by listening to them, by hearing them with these hydrophones in the water, or even hearing them just in the air as well. And they can identify these different pods, and they can also identify individuals by these. And what they're trying to do, here's like the ultimate goal right now in terms of like really understanding the sound. We're trying to develop a vocabulary. We're trying to develop a whale dictionary or an orca dictionary. And in terms of whales, the one whale that we're working on right now that scientists feel they're pretty close to already, and those are sperm whales. And we have a very extensive sound catalog that they are working with, and they're trying to identify what this language is for these animals, because they are communicating in a language. Each of the pods has their own dialect, slight differences.
Good morning, Kanava Panorama family. This announcement is for Anna McCardley. Anna McCardley to kindly contact their services located on Lopetec 34 by dialing extension 6676. Thank you.
These animals know how closely they're related by the sounds they produce. Using echolocation, and I think this will play. This is how echolocation works. Sends it out from the melon, comes back to the jaw, and they translate that into an understanding. An orca can know what fish, what type of fish is nearby, based on this echolocation. Who is pregnant? They can tell. Which pod members have eaten recently? They can tell this from echolocation. How is that possible? We're still trying to understand that. That doesn't make sense. It's like, it's not a language, really. A three-dimensional map of the world around them. And then the question is, if an orca's in the water with us and they're hitting us, what can they find out about us? And scientists are very curious about this, because there are cases where they're using this, for example, when we were talking about the manta ray and them being able to see polarized light. Well, scientists have been studying the eyes and they're wondering, okay, well, I wonder if there's any application here for us. And they think that they may have figured out a way to identify precancerous cells, as an example, by using this polarizing effect and looking at these when they're studying cells that are maybe suspicious, being able to look using this the same mechanism that the manna shrimp uses to be able to identify these kinds of cells. So you never know where this research is going to take us. And especially with echolocation, of course, we do know where that took us. Cultural knowledge, I'll talk about that in a second. Also, cultural knowledge among them. These are the Chugach transients that are located in that area. And on this chart, these are the ones that are located right here in blue. These are all the transient populations. And transient populations, they're basically three ecotypes of orca. And the ones that we see most commonly, like if you've been up to Alaska, those are residents and those are eating salmon. These transients, these are the ones that are eating the seals. And they move around. They have very, very wide ranges. Their ranges can be almost up to 2,000 miles up and down the coastline here. But these little guys are sitting right here. And this was a special group because this group was the group that was affected by the Exxon Valdez. There were 22 of them. There are only 7 left now. And this group happened after that shipwreck in the 1980s when that ship grounded and released all that oil. How many people know about that? Or is there anybody who hasn't heard about this? Most everybody in the world has heard about this. It was one of the most devastating wrecks and certainly brought up our awareness. Changed all of shipping forever, by the way, too, because prior to this, all these ships were just single-hulled, and now it's required that all these oil transport vessels have to be double-hulled, and that all came from the Exxon Valdez. You can see these guys, that's a picture of them swimming through there. They were the only pod to swim through that oil slick, and they are also the only pod that has not recovered or maintained their population. They lost almost 2/3 of their population as a result of that. This is a chart showing there are only seven members now that remain of that group. And they have they don't mix, even though they're sitting up there in the middle of all those other transients. These guys do not mix. They're still a very, very tight community. This was a book that was written, she's since passed away, but Salitas, Eva Salitas, she wrote a book, Into Great Silence, beautiful story of this orcapod population that she really spent much of her life studying and following. Here, they were the only group to pass over this bar, and I thought that was interesting. If you were in Alaska this year, we had an orca that passed over the bar into Tracy Arm, and it's the first time I've ever seen an orca do that, passing in there. And it was a transient population, and they were sitting there waiting for those harbor seals to come out, which they do after they have puffed on that reef. And this is what these guys eat. They're eating these harbor seals that are up there. 7 only that are remaining of that culture, which will be a loss when they're finally gone. The next, let's move on to this. For some animals, social interactions happen on a much larger scale. These are the blue whales. And you get kind of a size comparison there. Remember, these are the largest animals that have ever been on the planet. These animals weigh as much as almost half the people on the ship, one animal. So that would be two blue whales. These guys are big. And blue whales produce the loudest and the lowest sounds on the planet. Now, sperm whales produce a bit louder sound, but in terms of loudness and lowness, it is the blue whale for both of these. You can see right where that is. That's pretty dang loud. And they vocalize at a very low frequency, at 14 hertz. And if you were to compare it and see where we fit in on this, we sit right here. So we're about 20 over here to 30,000 is where we are. These guys, blue whales, are producing much lower tones than we can hear. And until we had instruments to be able to explore, as I was saying, we have scientific instruments to explore parts of our world that our senses cannot explore. And this is where we use these instruments. We didn't know that whales were producing sounds until very recently in this much, much lower.
Well, hello, and good morning, my Carnival Panorama family. Sandy Cruz ready to come in and let you know what's going on around the ship. Now, folks, it is the day that has the most important event possible.
Happy Halloween.
Right now, we're going to get started with our Groove for St. Jude. Now, this is the most important event of the entire cruise. Nothing that we have done so far this cruise has meant anything. Nothing has been important. It's all been for your enjoyment and your pleasure. But today, this is an event that we are giving back to the children of St. Jude's Research Hospital in Memphis, Tennessee. This is an important and incredibly hard-working charity. So, no matter where you are in this ship, let's go and donate to St. Jude today. Come up at 11:30. Come up and do some good and feel some good and get that good karma coming back to you. $12 gets you a t-shirt, but I know it's been a long cruise and maybe some of you can't afford $12 and that's completely fine. Maybe donate $5, $1, anything, any amount of money is worthwhile. So come and do some good and feel some good and raise some money. There is 3,500 plus guests on this cruise. If everybody just donated a minimum of $5, we would have more than $15,000, which is an incredible amount of money for not that much per person. So don't just think to yourself, everyone else will donate, I don't need to. Come and do some good. Take it in your hands and do some good and feel some good today at St. Jude. Coming up right now on Lido Deck. My goal for today is $7,000. That is my goal. That is my personal goal that I have set myself, and I think we can do it. $7,000 is the goal for today, but that's the minimum. I will stay on Lido Deck until we get $7,000. I'm going to shave my face. I'm going to do some auctions. I'm going to do anything it takes to get that $7,000. So come and join us for our St. Jude event coming up on Lido Deck right now. Our team are already there, so come and join us. We got lots of Halloween events going on around the ship, so make sure you go and check out our Halloween trivias, scavenger hunts, and all those different things that are happening. And of course, tonight we're going to have our Halloween costume contest. We've got bingo coming up at 12:15 for the sales, and of course 1 o'clock for the game. So go and join us for that. Whatever you do, folks, enjoy yourself. Relax after 2 days of being out and about. Relax and enjoy the ship. But until I see you next, enjoy the casino, enjoy the shops, enjoy the spa, and I will see you for St. Jude upstairs on Lido Deck at this time. Until then, my name is Andy. You've always got a friend in me, and I'll see you all very soon.
Somebody said the casino should match whatever we raise. You didn't hear that from me. Didn't hear that from me. That was somebody else. But somebody should challenge them. All right, so here's how these whales make sounds. Baleen whales, humpback blue, all those whales, they do not emit air when they make sound. When we make sound, we emit air, don't we? But these whales don't. They recirculate this air in their bodies, and they'll push air out of their lungs, and they'll just keep pushing this air in and out inside of their bodies. And those ventral grooves, for example, at the very bottom of their jaws, these baleen whales, those sounds are going to emanate from that part of their body out into the sound and out into the water. And these are low frequency sounds. Now I'm going to pull this out for you. And you may not know about this, but any of my military individuals, especially if they were with the Navy and working, they'll know about this. There is a channel, it's called SOFAR. How many people have heard about that, by the way? Any military here, Navy? SOFAR, did we talk about it? Somebody, I spoke about it with one other person. Anyway, SOFAR, excuse me, this is a sound fixing and ranging channel that lies at depth in our oceans. And we discovered this during World War II when we were trying to identify enemy submarines, Russian submarines, and so forth. And we discovered this channel. And in this channel, sound waves will travel through this long distances. And I put this up here on the right at about 1,600 feet is where sound travels at its very slowest. In air, it travels very fast. And as you go down in depth here, it slows down, and then once pressure comes in below that depth, then the sound is going to speed up as it goes through the water. And what you want for long distance sound, you want a low frequency, 14 hertz, and you want it to travel as slow as possible. And that, we discovered, was an area where whales were emitting sound. You can hear a blue whale singing off the coast of Iceland with a hydrophone, measuring that in the waters in Virginia. Those sounds from those blue whales traveled the entire distance of the ocean when they emitted in this sound channel here at about 1,600 feet. And where do sperm whales love to hang out? They love to hang out at about 1,600 feet. Blue whales as well. This is where they were able to communicate literally across the ocean with their sounds, their songs, and their communications. And that brings us up to this topic, which is how is noise going to affect them? And noise is probably going to affect these whales in terms of their ability to hear that, receive those signals and so forth. And one thing that we have noticed over the last 2 decades is blue whales' pitch has dropped. And that means that it's almost like they're going to a different frequency band. They're going down a notch. And scientists are very interested to see if this noise that is being created on the water is playing a role in that. It takes work to understand these animals, that's for sure. Let's talk just a little bit about some of these animals and the tools that they use. And a lot of this you've seen on television, YouTube channels, all that cool stuff. These animals coming up with all different ways of getting to whatever they're after. It takes intelligence, flexibility, creativity, and innovation. And there is plenty of creativity out there. Everybody's seen this. I'll tell you one little thing you may not know. These animals are not nice. I know they look nice, and I know they look furry. I used to have to go in at the aquarium and clean out their tanks. And I'm going to tell you, we would have to pull them out and put them in cages because they would rip us apart while we were in there cleaning their tanks. They like to eat these clams, mollusks that they pull up from the bottom. And you've seen these pictures with rocks. They have 2 different kinds of rocks. They'll put that rock on their stomach, or they'll carry it, or they'll find some stationary rock, and they're going to crack the shell. One thing that we learned, most of these guys are right-handed. it turns out. Going through misons where their shells, they leave their shells. We've found that most of those shells bear identification that they are right-handed. They will pass on their diet preferences, and they will also teach their pups. There's a certain element of innate behavior there as well, because even orphan pups, it turns out, are using these tools. And here's some other innovations. Here's an interesting innovation showing the cleverness of a dolphin here. This is in Western Australia. They found this dolphin that was taking a sponge, putting it on their nose, and then using that to help when they're looking for their food. They're looking for these barred sand perch. They'll use that as they're going through the bottom to protect their nose so they don't get all scraped up and cut. And that's a new behavior, which is very interesting to me because it means these animals are still innovating. They're not doing the same thing over again. And scientists are very interested in that aspect of these animals because that means that they're adapting. And as we know, our environment is constantly changing. It's changing now in many different ways that these animals may not have seen, and it's going to be very interesting to find out how they adapt. And another species that's going to be very, very interesting to watch is ours, and how we adapt to all these changes that are taking place. And if you look in the news, if you look out in the world, you see it happening everywhere, people adapting to this. They showed that this behavior has been passed down from mother to daughter in this particular instance. Sharks Bay, they also have seen them using shells to trap fish. Interesting. And there aren't just mammals that are doing it too. There are also fish. This little guy right here, orange dotted tusked fish. Let's find out what he's going to do, or she's going to do. This little guy named Percy, been studying, watching this fellow, going to take a clam and take it over to a coral reef, and she's going to find a hardened place for that, and she's going to break that open. She'll also find a place, these fish that do this behavior will also find places where they can jam that shell into the coral reef and then break it open in that method and extracting that food. How many people have seen this fish? These are archer fish. These guys will squirt water to knock insects down. There's a little bug, insect, it's going to squirt that water out, and this will learn behavior. And it takes practice. It's like throwing a football, or throwing a basketball through a hoop. You see kids out there, sometimes adults, maybe more adults than kids nowadays, and they're out there. Or go to the beanbag tournament. That's the place to go. And watch them over and over and over again. These archer fish do the same thing, except they're doing it for their meal. Again, thousands of times finally getting that. Here's an octopus again. These people are husking these coconuts. Octopus is just sitting down there waiting, going to grab one of the shells, and that octopus is going to make a home out of it. Very clever. Here are these guys, the giant manta rays. Remember, the wings on a giant manta ray, this manta ray is about as big as this stage. That's how big these guys are. They're huge. And they have the largest brain to body ratio of any fish. They're filter feeders, swim through the water, feasting on this zooplankton. They love any kind of spawning event. These guys, there's a spawning event, these guys are there. They'll change their color patterns as they're meeting new individuals. They'll swim in chains, and we've seen kind of similar to a way in terms of group behavior like bubble net feeding with the humpback whales. And these guys are all swarming around. They'll create circular cyclonic currents within that area, and then they'll just, the spawn will just funnel into their mouths. And they'll have a favorite friend, a BFF. Seriously, too, because the females hang together. And the juvenile males, here are the females, and they like to hang together. And that's what they'll do. They have this whole social structure. Males kind of out of the group. Juvenile, the kids all hang out together as well. And they have these different social structures. Also, they'll view their own reflection. They're one of the very few animals that will look at their reflection and recognize each other. And of course, scientists are very interested in that. What advantage does that give them? When do they see their reflection? I mean, we just know that they recognize each other, or they recognize themselves. And that kind of self-awareness, we just don't see very often in the animal kingdom. And of course, scientists want to know, well, what advantage does that give them? Why do they have the ability to do that? How does that help them? And then, of course, these guys, bottlenose dolphin, they have their signature whistles. Has anybody ever heard them out in the wild when you saw them on this last trip? Yeah. And they have this elaborate vocalization as well. Thought I would throw this in there just real quick. This is called the Dolphin Communication Project from a number of decades ago. It was a partially funded NASA grant where they were trying to understand more and more about the intelligence of these animals that we have learned so much about over the last couple of decades. They even tried to get the dolphin into the United Nations, which is interesting. They thought, okay, these are highly intelligent animals, and there was just one hitch to it, and that was nobody could understand the dolphins when they were talking. And it's the same thing with the whales as well. And one of the reasons, not to try to get them into the United Nations, but this whole project was all about, let's try to understand. Wouldn't that be amazing if we could understand? Because how many animals can we do that with? Not very many. And our communication with that whole other world and that whole experiential world. I mean, even take your dog, for instance. Your dog, next time you're home, if you own a dog, or maybe you know somebody who owns a dog, look at your dog's nose. And if you look at your dog's nose, you're going to see it's not going to look the same as yours. It's going to have that little circle part, but there's going to be a notch at the very bottom. And every single dog has that. Every wolf has that. And you might wonder, well, why is that? Why is that nose shaped differently? And here's why. Because when your dog smells, unlike you, the only time you can smell is if you do what? You have to inhale, don't you? And then when you exhale, do you smell? No. But your dog smells when it exhales and smells when it inhales because of that little notch. That notch produces a vortex, and that little vortex shoots that air back into your dog's nose, its sensory, olfactory areas, and that dog is smelling when it's exhaling and when it's inhaling. And not only that, your dog can smell 300 times a minute. If you were to try to do that, you'd be laid flat out. You would hyperventilate. But your dog can smell that rapidly. And your dog, when you're walking your dog's experience is nothing like your experience. Your experience is a TikTok experience, probably, while you're walking your dog. You're looking at your phone, you're talking, you're texting. But your dog is out there having this incredible experience. It will go smell this one spot. It can tell you the names of every single dog that visited that during the last week. Your dog can tell you whether that dog was a female or a male. Your dog can tell you whether that dog that was there 2 days ago was pregnant, not pregnant, can tell you all that information. Your dog can tell you whether the age of the dog that was there at that spot. Your dog can tell you whether that dog that visited was sick or not. And that's just one little aspect. So if you're walking your dog, make sure you let that dog smell and just appreciate it and just go, wow, I wish I could do that. I wish I was having this incredible experience that you're having while you're walking around. What was that?
Maybe not.
Maybe not. All right, so dolphin, they live in this world that's very, very different from ours. They see the world, and it's not just dolphin, but it's all of these animals have this amazing experience. Underwater brains allow these marine marine animals to interact with their environment in very, very creative ways, and not just marine mammals, but all of these as well. All right, folks, that's all I've got for you. Thank you for coming. That got longer than I wanted. And tomorrow we're